Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. Even though it's made up, it's probably an exam question because the question builds upon the next question, or builds upon the previous question rather. So we got a pump that is pumping fresh water from the lake to a tank at 16 meters high. We have a volume flow rate of 71 liters per second. The pump uses 15.5 kilowatts of electrical power. We ignore frictional losses in the pipe and any kinetic energy. We want to find the combined efficiency of the pump and motor. And we also want to find the pressure difference between the pump's inlet and outlet. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So we got a pump pumping fresh water from the lake to a tank, and it's 16 meters high. Step 2, list all the given variables, find the unknown. So they give us the electric pump of 15.5 kilowatts, the height is 16 meters, the volume flow rate is 71 liters per second. We want to find the efficiency and the change in pressure. Step 3, find the efficiency formula. So the efficiency of the pump and motor is equal to the change in mechanical power in terms of fluid divided by the power of electricity. So this symbol right here is eta for efficiency. So that's the Greek symbol. Step 4, find the mechanical power in terms of fluid formula. So it will be mass flow rate multiplied by the specific mechanical energy. So both of these are unknown, so let's find the specific mechanical energy. In this case it will be potential. So the potential specific energy formula is what we're trying to find. So it's gravity multiplied by elevation or height. Okay. Step 6, we just plug and play. So gravity multiplied by 16 meters multiplied by the conversion unit. So that will give you 0.15696 kilojoules per kilogram. Step 7, find the mass flow rate formula. So m dot is equal to rho v dot, rho being the density. Step 8, find the mass flow rate. So the density of the lake is fresh water, so that's 1000 kilograms per meter cubed. Now we need to convert the volume flow rate V dot from liters per second to meters cubed per second, so we need to divide by 1000. So we'll get 0.071 meters cubed per second. So if you multiply by 1000, you'll get 71 kilograms per second. Step 9, we can now find the mechanical power in terms of fluid. So we multiply the mass flow rate and the potential specific energy. So we will get 11.14 kilowatts of mechanical power in terms of fluid. Step 10, now we can backtrack and find the efficiency of the pump and motor. So we've got 11.14 kilowatts divided by 15.5 kilowatts. That'll give us 71.8%. So that is part A. Now moving on to part B. So to find the change in pressure, we need to derive the formula. So using the power from the mechanical fluid, we get this. We get mass flow rate multiplied by the final pressure minus the initial pressure divided by the density. Now they're referring to the density of the lake. So we know that mass flow rate is density multiplied by volume flow rate. So both of these densities will be cancelled out. So that's how they got volume flow rate multiplied by change in pressure is equal to the change in mechanical power in terms of fluid. So now we just rearrange by dividing volume flow rate on both sides. And this is the formula that we've derived. So step 12, to find the change in pressure, we divide the change in mechanical power in terms of fluid by the volume flow rate. Note that we need to convert kilowatts to kilojoules per second so we can cancel out the units. So it's a one-to-one conversion. 1 kilowatt is equal to 1 kilojoule per second. So 11.14 kilojoules per second divided by meters cubed per second. So then we multiply by the conversion factor to get into kilopascals. So the change in pressure is 156.9 kPa, kilopascals. So that means we need to boost the pump by 156.9 kPa in order to raise the elevation by 16 meters. Note that only 2/3 of the electric energy consumed by the pump is converted to mechanical energy of water. The remaining 1/3 is wasted because of the inefficiencies of the pump and motor. Disclaimers: the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now before we leave, I highly recommend that you save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, you can use the Mac equivalent of snipping tool. If you never used it before, follow the instructions, click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program. Once open, click on video option, then click on new. Left click and drag the rectangle to cover the YouTube screen. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.